And building molds for the aerospace industry panel discussion is about to begin. May I invite the moderator, Mr. Vineet Seth, MD India S Asia Middle East, Mastercam. Next panelist joining us, Dr. Ravi Guttal, a Senior VP and CTO for Aequs. We have Mr. Rakesh SB, Vice President, Aerospace, Sansera Engineering Limited. Our next panelist, Mr. Maneck Behramkamdin, Business Head, Godrej Aerospace, joining us. Let's welcome S. Ravishankar, Chief Scientist and Head, Aircraft Prototype Manufacturing Facility, CSIR, National Aerospace Laboratories.
Good afternoon, everyone. Generally, I'm not for any posturing, but it's indeed a pride moment that India landed the Chandrayaan-3 yesterday. And since I said I'm not for any posturing, I cannot but say that Mastercam has also landed on the moon because we were a part of the ISRO manufacturing facility that landed the Chandrayaan up there. But that's not the best news here. We have someone for which I would request a standing ovation, who was an integral part of the Chandrayaan journey. Maneck, please take a bow. And I think Godrej was... Congratulations, Maneck.
Thank you. I think it was an honor to be part of that journey, and Godrej and Boys is humbled to be honored this way. So it's not for me to take the honors, it's for the company, which has been working with ISRO for a long time. So thank you once again for the recognition.
Right, so welcome to this session which talks about die mold and the importance of die mold in the aerospace industry. Before I begin, let me roll out some numbers that I have gathered from information sources. The global tooling market is estimated to be about $115 to $120 billion. This includes die mold and jigs and fixtures. We are not talking machine tools here. Aerospace tooling market is considered to be around 20% of it in value terms. The Indian tooling industry is estimated for the aerospace industry is only about $100 to $150 million. So there's a big gap and a big opportunity there. So that's a wide gap remaining to be fulfilled. And the whole industry is expected, the aerospace tooling industry is expected to grow at an 8% CAGR over the next 10 years, which is nearly doubling it or more in the next 10 years. And bulk of this tooling in India is consumed by a few players. Now, that sets the kind of tone for the discussion today. And I have these guests with me who are stalwarts in their own domains. And I would start with the person on my very left, just to the left of me, Ravi, who is the Senior VP and CTO of Aequs. You've been in this manufacturing industry for a long while. How do you see the role of innovation and advanced manufacturing techniques in meeting the stringent requirements of the aerospace toolmaking?
Yeah. Thank you, Vikram. There are a couple of challenges, apart from the engineering requirements, a couple of challenges for aerospace industry tool makers. One is the volumes are very low, and the number of parts the tool actually makes is anywhere from 500 to 1,000 per year. Unlike the automotive industry or the consumer durables industry or the toys industry, the numbers are very low. So the tools have to be amortized over a smaller number of parts. This leads to very capital intensive investment from the tool maker as well as on the OEM. So the tool costs have to be reduced. So we have to go with soft tools. The precision has to be maintained because you are serving a aerospace OEM or a tier 1 supplier. So that's the challenge, the first challenge we face. The second challenge we face is the changeover time. Because we are doing smaller lots, the changeover between the parts, you have to have inbuilt designs such that you have a shorter changeover time, like SMED, single minute exchange of dies. So the tool design should have quick changeover time. Apart from that, we recently entered into the aerospace interiors industry. So there are a lot of aesthetics, like if you fly in some of the aircrafts in the business class, a lot of aesthetic requirements also on the seating, on the dividers. So that coupled with low number of parts, a smaller number of parts, is a challenge for tool makers. Apart from the engineering challenges of high precision, the texture and surface finish required on the parts. Then the other part is on the thermoplastics. So when we go to thermoplastics, obviously every gram of material removed from the aircraft adds to the economics of the aircraft. So thermoplastics typically have high abrasion because they are fiber filled, and at high temperatures, they melt at higher temperatures. So that the tools have to take care of the higher temperatures and higher abrasion also. So these are the few special requirements for aerospace molds.
So I'm sure the expectations from the aerospace industry are pretty high, but what criteria do the aircraft components and OEMs have in terms of quality, performance, and more importantly, delivery of molds or the time for the molds?
Quality, of course, is in very stringent aerospace quality standards, especially the part has to be very durable. So if you have surface flaws on the parts which are induced because of the quality of the mold, then it becomes a big challenge. So on the durability, obviously the part durability depends on the mold design also on terms of surface quality. So that poses a challenge.
Typically because these aircrafts, especially the commercial side, have long lives.
Lives, yeah.
So you mentioned soft toolings as well. Does it dovetail into the requirements of the quality of the parts?
No, soft tooling for the interiors. Yeah.
And in terms of the delivery timelines that you have to sometimes work around?
Luckily, the delivery timings, these are long programs, so we have a little bit leeway.
Play out there.
Leeway on that.
Wonderful. As an organization that has deep roots in innovation, how do you handle Industry 4.0 in your aerospace programs, especially for die and mold design and production?
So on the Industry 4.0, we have 3 or 4 aspects of Industry 4.0. As you know, Industry 4.0 has several tools. One of them is additive manufacturing. So if you use additive manufacturing, we can have conformal cooling for the molds, which reduces the cycle time for cooling and reduces the warpage in the part. Conformal cooling, if some of you may not know, or I'm talking to the choir, but the cooling paths are very close to the surface. So that can be done using additive manufacturing, metal, either SLA, SLS, or electronic deposition, or direct energy deposition, or sintering. So that can help in terms of the quality of the part. That's one of the Industry 4.0. Then the second one would be the industrial IoT, if we have the molding process itself monitored using smart tools, like we saw in one of the presentations from Fibro on the stamping side, can we have smart tools which can give information about the temperature, pressures? Already there are machines which do that, but can we enhance those data collection points and to get a better part out from the molding? That's the second one. Then the digital twin is another Industry 4.0 vertical. I believe Industry 4.0 digital twin in particular is old wine in a new bottle. Because we were doing parametric analysis of the process. We were doing regression models. We were doing statistical analysis. The digital twin is just a new name, but some of the visualization of either through regression analysis or from physics, like mold flow, CFD analysis, is a must for getting the first time right molds, or reducing, you cannot get first time right molds, reducing the number of iterations in the mold.
Thank you. In case there is time, I'll come back to you with some other questions, but I'll move on to Rakesh, who is the Vice President Aerospace of Sansera Engineering. You had a journey into this segment. Can you explain about the strategic advantages that tool makers can gain? Because the audience is quite varied and quite inquisitive, by focusing on the aerospace sector. So,
thank you. In fact, Sansera, in 2010, we wanted to diversify. So we had two choices. One was aerospace, and then the other one was getting into medical. So we chose aerospace then. I think we did a right decision, and we have done quite well in our journey till now. So as far as the advantages, what we are talking for the tool makers, one is, I would like to give mainly 3 points. One is the diversification, the strategic advantage what you can get. I see many of the automotive and people in other sectors who are there have already migrated even into aerospace, which has given them a lot of advantages in terms of growth of their business, diversification. When I say diversification, it includes even the skill set. Because when you come to aerospace, the requirements are stringent. The quality requirements are different. Even within, if I take the OEMs, the same OEM from different countries, the requirements are different. So understanding the requirement is very important. So this knowledge and know-how definitely will take you to the next level. So this is as far as the diversification is concerned. And the next one I would say is the growth. Why I'm saying growth is, in aerospace, it will not be a short-term business. Normally it's a long-term business. So you have a predictable long-term business, guaranteed. So whenever you have a business awarded to you, it will not be just for 1 year, 2 years. It will be normally for a 5-year contract. So if you see the value, it's very lucrative. But don't get carried away by the value, because there are a lot of things you will have to work on before you execute that order. So this is as far as the growth is concerned. The third one is the reach. You will have an excellent reach globally. So once you get into this field, your reach is very good. You get to know a lot of OEMs, tier ones. The reach also is something different. The fourth one, of course, I'll add one more, the financial success. Because the business is quite big, definitely if you are on the right path, you will succeed. And many of them who are into automotive or other business who have migrated are very successful today. And I would proudly say, even in India, the aerospace industry has matured very well. And we are ready to take on that. Yeah, these are some of these strategic advantages what I see for the tool makers if they want to migrate to aerospace industry.
Yeah, interestingly, you mentioned not getting carried away with the financial success, because obviously it's a tough business to be in. So how do you handle the precision and complexity challenges in aerospace molds and dies?
See, today, let me start from the design of the toolings itself. Today, you have excellent softwares. Like we are just talking, we have one of the most reputed softwares is from Mastercam. Like that, we have many other softwares where 96 to 98% of the validation today can be done using these softwares. Gone are those days where we used to design something, take a trial, check, do the testing, and then again correct the molds or whatever it is. Because today we don't have time. Time is very short. The lead times to develop a tool is very short. Everybody wants a quick change. So fortunately, we have very good softwares today where this validation can be done to an accuracy levels of almost 96 to 98%. So with this, I'm sure that this industry is picking very fast and it's meeting the customer requirements. Then comes the machining. So we have a lot of latest machines available globally. Whatever machines is available in Europe, in Japan or US is also available in India. We have been using them. We have the skills to run these machines. So machining is the second one where complex things can be handled. I am sure that even in automotive and other areas, very complex molds are being built. So it's only like you need to understand the requirements of the aerospace industry. All this comes not just like that, but it goes through a learning curve. But I'm sure it can be shortened today because of the maturity levels what we have across the globe. And as a country, of course, yes, there's a lot of maturity in this industry. And third one would be the inspection, the measurement and inspection, which is very, very important. The method of inspection. The same component what you have produced, your method of inspection are two different ways, you may get two different readings. So understanding the specs and the requirements of the component or the drawing, you have to select the right method of inspection and the measuring techniques, measuring equipments, very, very important. So you may produce a good part, but you may declare it's not a good part because your method of inspection is not right. So these are some of the complex things. And one thing I would like to share here is consuming the requirements of the specs, very, very important in aerospace. And even if we neglect a very small thing, you know what can be the disaster. The quality standards are very high. I'm sure you're all, many of them, I think, are in automotive industry here. If you are driving a car, you have a problem, you can park the car to the left side and see what is the problem. But you are flying in an aircraft, if you have a problem, you have no space to park there. So this is the kind of requirement, the safety norms, the quality regulations, what are required in aerospace industry. This is the first thing which we have to understand. So the method of inspections, the quality requirements are very stringent. And we should not be deviating anything. Because in aerospace, I see there is no escape. You cannot escape a deviation. Today you may escape, but you will get caught somewhere else. And whenever you have a deviation, it's better to declare and see how to correct that then and there itself, rather than getting into a bigger problem later. So I would say that a lot of learning goes into this and a lot of challenges. Of course, even in supply chain, we have a lot of challenges today. Post-COVID, supply challenges are very high, raw material availability, the kind of raw material, alloys, especially the steel alloys. You have money, you can buy gold in the market today, but if you have money, you cannot buy the special alloys used in aerospace industry. I have gone through this. So the specs are very, very stringent. We have to follow that. We don't have a choice. There's nothing like something we have an alternate or option. It goes through a different process if we have to do that. Yeah.
So yeah, obviously we have a very ambitious bunch of tool makers in this room who are, who want to expand into different territories. And given your experience having diversified into aerospace, in a few bullet points, if you could tell us what advice would you offer to the tool makers in this room and beyond in India for venturing into the aerospace industry?
The first point I would like to mention is you should have a lot of patience and passion. Both should be there. Because in aerospace, the gestation period is very long. Unlike in other industries, you make something, you just see the money coming out. But in aerospace, it's not so. But of course, this curve, I would say, has shortened a lot over a period of time because of the various new advancements in the technology, as I said, the softwares. Of course, it has shortened, not like the earlier days. That is one thing. The second thing is, there are certain requirements before you get into an aerospace business, like minimum you should have an AS certification, certification which is very, very important. And if you are into special process, surface treatment, definitely you need NADCAP approvals, similar to other certifications what you have. These are some of the important things which one has to keep in mind before getting into the business. So my advice is, definitely, I know many of you are very keen to get into this. A lot of opportunities are there. I think India has the highest youth power. We have all the necessary things. We have enough land, enough infrastructure, enough people. So where this is the shortage in other countries. So all the opportunities coming to us, we should make use of this. This is the right time, I think we should show our capability. We have all the skills. We have all the requirements to cater to this industry. I'm sure with the kind of experience we have here, many of you are highly qualified in these areas. I'm sure we can take this industry to a different level in India as well. Just to give you an example, which correlates to yesterday's success of Chandrayaan. Last September, I was in Spain for one of the aerospace exhibitions. Then that day evening, over a dinner party, I happened to meet the Airbus Chief Procurement Officer. So I just met him and said that we are from Sansera and then from India, and only country representing in this exhibition. He was so happy. You know his remarks, what he made? He said, "You people are overtaking us." This is the statement he made in September, and he mentioned ISRO is doing wonderful job. So you can imagine people around the globe are aware what is happening in India. He knew this, what ISRO is doing, 6 or 8 months before even we saw this success yesterday. So that's the kind of confidence the whole world is having on us, and we should live by that. Thank you.
Thank you, Rakesh. Thank you very much indeed. And I'm sure that the ambitious and the successful tooling fraternity here would take a leaf out of your book in terms of diversification and move into the aerospace industry and make a success of it there as well. Moving on to Maneck. Maneck, thank you for being here again, and for the tremendous success that you have had recently. I would like to start and begin by asking, how does the demand for aerospace components impact the tool-making sector? And what potential does it hold for expanding business in general?
Yeah, thanks for this opportunity once again. Aerospace sector, I think, has been well explained by the two speakers before me, Ravi Saab and Rakesh Saab. So I think some of you must be already a bit scared of entering into it after listening to the stalwarts over here. But I come from an industry which is not aerospace. I'm just 2 years into aerospace. So I'm telling you, if you keep your basics correct, aerospace is also not something which you cannot enter into. And as they said, there is a huge amount of potential. The potential in terms of domestic requirements, in terms of commercial airlines, the OEMs of the world are entering and coming into India because of our good on-time performance and quality performance. If you ask me from the data what we have and can be also shared by the team over here, India was the only country who could achieve on-time performance and the quality performance even during the COVID period. So that has given a lot of confidence to the world OEMs to keep on pushing new components and new products into India for a tier 1, tier 2 kind of supplies. But in the same breath, we are not into design, and that's where the ambitious projects of HAL and NAL over here needs to be reinforced and complemented. And the toolings for that also, there are a huge amount of requirements which are there from the industry. What is important is to understand the complexity of aerospace in terms of special materials, special alloys. Uh, Whereas it is difficult to do things first time right, but at the same time it is important to do it first time right because the value attached to those kind of alloys is very large. So how do we do mock-ups with similar material? How do we do more simulations? Is something what the tooling industry needs to come up with. Today we don't have an end-to-end solution provider, if you ask me, who could design, build and test a tool like you do in automotive. A lot of things have to be partnered by the companies like us. So do we have anyone who can do an end-to-end solution? What you do for automotive, can someone come up and say we can do it for aerospace? And that is where the next leap we can take in the industry. So yes, huge amount of requirements, but I think from a scale of 1 to 10, we might be at about 4. So the big leap which we need to take from the tooling industry side.
Great. And also, coming from an organization like yours, what kind of digitalization tools and modern tools like Industry 4.0, the done to death, acronym, what are those things that are using to improve or enhance your production facilities, to work with your suppliers on data validation and sharing? What kind of tools are you using and how are you using them?
Industry 4.0, like any other industry, is very critical for all the manufacturing functions of aerospace industry also. The connected shop floor, what we talk about, whereas each machine talks to the other. The toolings give us feedback. I think it was explained earlier by Google that how the toolings would talk to the cloud, and then you get the information. So all those kind of processes what we put in place. Press brakes, how the press brakes will give information online in terms of spring back, in terms of what you call as moldability. So those are the kind of IoT sensors which we have put into our presses and our press brakes to give us the feedback. At the same time, there is a big gap, I would say, today to understand what is relevant to the industry. Sometimes we overdo the design and increase the cost. So a relevant IoT is something which we need to understand and put in our systems to be competitive. Like he said that years back we used to do a lot of trials and errors, and now is the time that we need to be 99% correct on the first go. So IoT will help us to bridge that gap, do more simulations. Also software tools, use 3D printed tools for doing the trials, because the FAIs which are required by the international OEMs, while we have some liberty in terms of launch gestation periods, but there are some packages will come with very short lead time, especially now when the engines are in short supply, and we being in engines programs across all the OEMs, including the Indian program. The lead times given are very short. So how quickly we can make the molds, try them out, and these are the molds which require sometimes hot forming, sometimes spinning, hydroforming. So all these kinds of requirements which are coming up, and there's a big gap to be covered from the industry side to get these kind of molds in a shorter period of time with first time right. So more simulations, more sensors will definitely help us, and build in that little bit of IoT to give us that feedback, and do it enough so that we do not make it out of our pockets. So correct IoT is something which I would stress on for the industry to apply.
Does it also help you in your communication and therefore confidence and comfort with your customers to adopt these?
Definitely, whatever we do in terms of IoT and in terms of visual manufacturing helps to give the confidence to the customers. Also not to the customers, but our methoding people and our tooling people back onto the offices. They get on-time feedback, online feedback, and the corrective actions in the the kappas can be taken more easily and more frequently rather than at the end of the line. So definitely it helps us to improve our kappa rather than doing it offline. It becomes more online.
Perfect. Finally, what would your thoughts be on the factors that contribute to the success of tool makers in meeting the demands and the stringent expectations of the aerospace sector?
So as we said earlier, understanding the parameters required for these special alloys, and 2 years back I did not know that there were so many special alloys available. We used to talk about MS and stainless steel, but every number which changes with the alloy has a different parameter, has a different formability, has a different kind of heat required to form, has a different kind of stretch, has a different kind of draw. And unless we understand these parameters, the design of the tool becomes very difficult. So here I am talking about only the forming tools because these are the most difficult ones which we face today in the industry. There are other tools like fixtures, gauges, dies, we are good at. We can make them, we can design them, industry is good at that. But forming dies is something which there is a challenge, and more simulation we do, use good software to do simulation, the easier would be to convert them into the actual live molds which are required by the aerospace industry. So first is understanding the parameters, do more simulation, and then of course do an end-to-end possible option where design, build and tryouts is something what I would request the tooling industry to look into. And even if we get 3 or 4 good houses to work for us, I think it should be enough, because volume is, again, as pointed out earlier, not that big. So 2 or 3 good houses from whole of India, I think should be enough for at least next 5 years.
Thank you very much, Maneck, for your insights. I'm glad to say that the organizers would be pleased we are on schedule, more or less. Thank you. Right. So before I move to the last speaker or the last panelist here, Dr. Ravishankar, Chief Scientist of NAL. Thank you very much for joining us. You are in a tough trade yourselves, and you do a lot of innovative work. How do you handle precision and complexity challenges in aerospace molds and dies or aerospace production?
Thank you very much for the introduction. Well, when you are talking of challenges in mold and die design, particularly from the aerospace sector, there are 3 or 4 points that one could look into. The first one is essentially probably the material selection. When you are looking for a stable mold with probably a high volume production, which is probably sometimes quite rare in aerospace industry, but having high tolerances, and the mold size probably being from small to medium size, then one should look at Inver as a material to use. On the other hand, when you are looking for low volume production or low cycle production with fairly reasonable tolerances and large molds with doubly curvature surfaces, then you could probably look at composite and varied varieties of composite materials as an option. So metal selection would be one area where one should seriously look at. The second option probably would be the design methodology that you would apply. The design methodology should take into consideration issues like having a single mold or an integral mold, and also want to take into consideration ease of manufacturing, ease of mold removal, and also look at how close the mold is able to, the part or mold is able to adapt to the near net shape, so that you can directly go for final machining, which will give you the necessary accuracies. And also reconfigurable molds is something that the design team also should look at when we are looking at the precision of aerospace molds. The third thing that one should also look at is the reference system. That plays an extremely crucial role in mold design, both in terms of manufacturing as well as in terms of certification of the mold and acceptance of the mold. We normally call it as OTP in aircraft parlance, which is optical target points. These are highly accurate OTPs which needs to be manufactured and machined and inspected. That is another thing that they should take into consideration when you talk of precision among molds. Other thing that one should also look at is probably a proper electroplating technique or coating system That should take care of the wear and tear of the mold as well as the durability of the mold. That is another thing that one should consider into fact. And the last one, probably I would say that usage of high precision CNC machining centers along with a good CMM and trackers for large scale molds will help us in giving a good, accurate and high precise molds.
Wonderful. Wonderful. And being a government organization, how do you collaborate with research and other industries for aerospace mold and die advancement? Do you conduct research programs along with other organizations or institutes or the private industry, and how do you go about it, and how can mold makers be from the industry be a part of it or gain from your insights?
Well, when you talk of research and development in the aerospace mold space, there are, the first thought that comes to one's mind is that this is quite a fertile area for R&D. There are quite a few imponderables, there are quite a few things that we still need to understand. And the first thing that probably we should look at is in the area of reconfigurable molds. That is one challenge that people have to look, that is adaptive molding, which will probably take care of a series of near-shaped components as a one single mold with certain modifications, but at the same time taking care of issues that always bother us, that is the spring back as well as the warpage, which is for various materials and various combinations has a variable parameter. That is one area of research that one could probably look at. The second area of research is the longevity of the mold. How exactly can we say can we assure durability of the mold against wear and all that? That is another area where we could have a research look. The third one probably is, as already mentioned by our fellow panelists, regarding the digital twin, the usage of digital twin, as well as the computational tools, essentially to understand the various parameters such as warpage and shrinkage that comes here. That is another thing that could be done, including predictive modeling, but is another area of R&D that could have. The fourth probably area of R&D that one could look at is in the area of smart molds, where you have sensor embedded molds, which will probably capture all the information that we want to have, various parameters in real time, particularly from our composite manufacturing side to look at issues such as real-time resin flow. That is something that we have some problems, and that is one area of good research that can have. And the other area of research probably is sustainability and eco-friendly molds, is something that one should also look at. And when you come of collaboration to these areas, which probably bother most of us, is we do a lot of interaction with the academic circle. We have interactions with the Indian Institute of Science, IITs, and a lot of colleges. And we also propose, through our CSIR, we have a collaboration where PhD is one of the areas where people work, and these are one of the subjects that the students take up to resolve these primary issues.
Glad to hear you're already doing a lot of collaboration on research. Yeah. Can you also, probably the last question for the evening today, but can you also share some cost saving or efficiency improvements in aerospace die and mold production or part production?
Well, that goes without saying that cost is critical for everybody. And more so in aerospace, where my colleagues will probably tell you that the margins are not that high. So cost is a primary parameter. And when you talk of cost, one thing that one should look at is minimize complexity in a mold, wherever possible. If there are certain features which could probably be eliminated, don't go for it. Minimize complexities, and also simplify your design so that you reduce your manufacturing cost and you reduce your total time of availability of the mold. The second thing probably one should look at is invest in high quality raw materials when you are making a mold, particularly in case of high production cycles, so that you don't have to reinvent and reinvest to make a new mold again and again. So that would be much more cost expensive and all that. And also, when you are going for low prototype development, go for cost-effective molds, which would probably be much effective for you when you are only for prototype development, 2 or 3 or 4 components that you are trying to make and give it to the vendor. The third thing that one should also look at is, of course, precision is important, but there are times when designers give you certain highly close tolerances out of their own this thing. That should be avoided, because any close tolerance is extremely cost dependent and time dependent. Try to avoid that if you feel it is totally unnecessary. The fourth probably thing is that you should, in aerospace, everything has to be documented. Yeah, there is no option. Everything needs to be documented, and you need to work as per that document. There are no two rules on that. So document and standardize your production process, and share that best practices with your production team, so that there is a uniform methodology of working in that whole ecosystem of manufacturing in your organization. That will certainly reduce the cost to quite a bit. And also see if you can have a standard inventory for all your molds. So that is one more area where you could probably look at. And the other one that one should seriously look in mold industry also is, from the aerospace perspective, is use of additive manufacturing. When you have a complex shape, when you have to remove enormous amount of material, additive manufacturing is a wonderful option for all of us. So that is something that one should look at. Then the other one, of course, goes without saying, high-speed manufacturing. That has to be important. That is where you get your finish. That is where you get your save your time. Initial expenditure may be a bit high, but that's a very good solution for cost saving.
Thank you very much, and thank you all the panelists for your insightful thoughts and vision for the die and mold industry's progress in the aerospace segment. And as all the esteemed tool makers in this room and beyond have made big strides in the international scenario, I hope that they would continue to do so in the aerospace segment as well. There's also a session, I believe, by Mr. Mohanville, if he's in the room here tomorrow. The last session is to how to prepare yourself for aerospace industry. That I think will also be very interesting. Nonetheless, I leave you all with these panelists' views, thoughts, and vision for tomorrow. And may you all get into this progressive and lucrative industry going forward. Thank you very much.